So the question is given like this: a box contains apples which are arranged in m rows and n columns. Some of them are fresh, rotten, and empty. And rotten apples affect adjacent apples, and it is given not diagonally. So it means that if there is an rotten or an apple and there are fresh apples around it, like this, 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 and this will be affected, but the diagonal apples will not be affected. So this is the meaning of this line. And then we have to find the number of fresh apples after t days. So we will be given t, and so we have to find the number of fresh apples at the end of the tth day. If it is 0th day, then the number of fresh apples will be the number of fresh apples given. So we will be given an input which is an m by n grid, and we are given t, the number of days. So the next m lines contains n elements. So if we take the example like 3, 3, 2, 0, 1, 1, 2, 1, 1, 2, 1, 1, and if I say 0th day, then all the fresh apples will stay fresh. So there will be 6, 6 will be the answer. But if I say first day, then some of the apples will be rotten. So how to find which apple will be rotten and which apple won't be? So this question can be solved by using this. So if there is any rotten apple, it can affect the apples which are on the four sides of it. So if I take this as origin, then it can rotten the it can affect the apple at 1 0, and another one will be 0 1 and minus 1 0 and 0 minus 1. So if I consider the rotten apple as the is placed at the origin, then these four apples at these points will be affected. So this way is a basic DFS. We have to traverse through all the elements which are adjacent to the current element. So if I want to apply this here, you can check that this first I have to check for this apple. So this apple will be affected. This apple will not be affected because it is diagonal. So this apple will turn into 2, and this apple will also be affected. So I am converting it into 2. So at the end of the first day, we will be having 4 fresh apples. If I want to find after 2 days, then I have to take count of these apples too. So if I consider this apple will also be rotten, this apple will also be rotten. And if I consider this apple is already rotten, this apple is already rotten, this apple is fresh, so it will affect this. So at the end of this second day, we are having only one fresh apple. And if I go to the third day, this apple will be rotten by either this apple or this apple. So this will also be rotten. There will be no fresh apples. So at the end of the fourth day, there will be no fresh apples. So how can I solve this? So in order to solve this, we have to traverse through all the adjacents of a particular apple. If I consider it again, like this one. So if we have to check where are the rotten apples, and so this is one rotten apple, this is one rotten apple, and this is one rotten apple. And now I have to find which apples will be affected by these rotten apples on the day 1. So I have to maintain a list of these 3 apples, and I have to find which apples will be affected. And after the day 1, I have to maintain a list of the newly rotten apples. Like on the first day, this apple will rot this apple, this apple will rot this apple. So this apple will be rotting this apple, and this apple will be rotting this apple only, and this apple can rot this apple and this apple. This apple will not be rotten because there are no adjacent apples on the day 1, but on the day 2, if I check, this apple will also be rotten. And uh, what can I do? What can we do basically is we have to find all the rotten apples. The step 1 is find all the rotten apples and store their indexes. Then apply BFS for each apple, each rotten apple, and find whether the adjacent apples are fresh. There will be two conditions. If it is fresh, then this apple will be affected. And insert this rotten apple into our list, into rotten apple list. And if this is if there are no fresh apples, then we don't have to do anything. And after passing through all the distance of the particular apple, delete that particular apple, rotten apple, from the list. So I will take the example, and so this will be fine again. I will consider the same again. It's a 3x3 matrix and time is given 2, and this is given as 0 1 1 2 1 1 and 2 1 1. So this is our grid. So our first step is find all the rotten apples. So here is one rotten apple and here is one rotten apple. If I insert these rotten apples into a queue, then this one will be 1 0 and 2 0. That's it. So this queue has 2 rotten apples, and will select this rotten apple, and I will find all of its adjacents. On the left side there is no elements, so we have to check this is one of the base case. And then we have a rotten apple on the bottom side, so we don't have to do anything. And there is a fresh apple on the right side, so we have this apple will affect this apple, so this will convert into 2, and we have to insert this into the queue, which will be 1 and 1. Now I have to check the top element of this, and this is there is no apple here. And now I have to go to this and I will delete this element from the queue, and I will pop this element. Now I will take this apple, there are no top, there are no left and bottom, and the top apple is already rotten, and there is only one fresh apple on the right side. So this will rot this apple, and I will insert it into the queue, which will be 2 and 1. So this will conclude my day 1, or t equal to 1. The starting is t is equal to 2. Now t is decreased by 1. So these are the 2 apples which are remaining in the queue after t is decreased by 1. Now I will select this apple and find which apples will be affected. This apple will be affected and this apple will be affected. And because of then I will insert these 2 into the queue. So I will insert 0, 1, and this one is 1 and 2. I will insert those 2, and there is already 2, 1 in the queue. So this apple is affected, this apple is affected. and because of this 2 comma 1, the apple which will be affected is this apple. So 2 comma 2 will be inserted into the queue and this will be deleted from the queue. So these are the 3 apples which are written on the day 2. And now if we decrease the t by 1, t gets 0. So this will be our final answer. Now we have to check how many fresh apples are still remaining. So this only apple is the fresh. So this is our answer. Well, we can find it by checking how many number of ones are still there in the grid.